Hi. Here I continue with looking at a black hole. Here we have a picture. Again, right here is the observer. Right here is the center of the whole region. I wouldn't say the center of the whole, but center of the whole region. Different story. Here's the event horizon. Then these are the paths of light like geodesics in the space part. So in other words, this right here is the projection onto the space part of the Schwarzschild geometry. Okay, so these are the different paths. Notice that this one takes like a curly Q type of thing, and then there's other curly Qs that are a little bit less pronounced. They go down here, and then it opens up more till eventually, you know, they're more sort of pretty straight arcs. Okay, looks like a beautiful picture of the celestial rooster here. So in any case, we have this, and now we ask the question again, what would a guy positioned right here see, right? What would an eye or a pinhole camera positioned there see? And then you notice something. If an object, or let's see, in this direction right here, the one that's got this curly Q right here, right? Say there were three objects located right here. So there was one here, another one here, and another one here. Okay? So you'd look in this direction and you'd see this object. You'd look in this other angular direction, and there you'd see this object. You look in this other angular direction, and there you would see this object, right? Okay. But also, had you looked in this direction right here, the one for this one, in the curly Q direction, right? You'd see three things aligned. So you'd see this basically in your picture. First you'd see one thing here, one thing here, one thing here, and then you'd look and you see one thing, then right behind it another one, right behind it another one. These here correspond to these angles right here, right? So it's starting from the center, these angles, and then this one down here would all be along this angle with the curly Q curve is. All right. So another thing is this, the famous Einstein rings, right? So that would be the case. Let's say you have an object located here, right? Well, since this metric is symmetric about rotations, but the central axis, notice that light that this guy releases in this direction would go to the observer, right? But had it been any other direction, sort of, you know, rotated outside of the plane of the board, you know, that rotation of this curve right here, again, you would receive light from that, and to the effect for the observer, what would happen is in those directions he would see a ring. So for things located on the central axis, right, so long as there's one of these light-like paths, you know, the space part of the light-like path that actually passes through the point, since you have symmetry about that point, anything located there you'd see a ring. So you'd see a ring from something here, but also you'd see a ring from something there, and even in the curly Q one, right? Because if this curly Q right here is a solution, one emanating right here from the bottom would also be a solution, and you know, any rotation thereof. So if an object was here, you would also see it as a ring.